Hey folks, thanks for joining me. I had a thumbnail set up and everything. This is my first live stream, and I really wanted to have an introduction that I set up on the Canva with some cool pictures and stuff. But today we're going to be talking about some myths about cannabis and destroying those myths. I listed 5. So let's see. Dry farm. People think you cannot dry farm cannabis, so that's the first myth. People think that you can't grow it in cold weather, so that's another myth. And let's see, people think that you need to feed it like a wolf, and that's another myth. So there's 3 right there. People think that you're not going to get quality cannabis if you try and grow it without perfect conditions, and that's a major myth. So there's 4. So 5th one would be that you can't get your cannabis seeds that you have all hybrid to grow well in nature. So the prompt of this video, though, is what I really wanted to talk about was this is like the time of year that you want to go ahead and dry farm plant for a lot of places. And other places it's going to be in the spring. But direct seeding allows things to happen that you can't do with a transplant. And so the taproot is the number one thing that we need for this to work. And so just like planting garlic in the fall, right? You don't want to plant it to where it's going to pop up and expose itself and get frost killed. Areas that are going to freeze hard, you might want to avoid the fall planting unless you get this good snow layer that comes in and insulates, or you don't have super hard freezing. But what I'm going to do here right now is show you. We had so we've been at 40 the last 2 nights. We've been pretty mild at fall, but we've had some hard freezes, and it was down 26 with a breeze, and then 23 2 nights prior here. And so what I want to show you right now, if I can, I can't really do the mobile, but what I've got is I'm working on my Chromebook. So let's see if I can do this without everything flipping around. And what I'm going to show you here, hopefully I'm going to move this around so you hopefully see this. These are Hindu Kush seedlings. And I'm sure more than this 3 fell out, right? But they're growing and they're just fine, right? And so that's one of the things. They survive 23 degree Fahrenheit. No problem, right? Everything out here, there was water in containers that were froze solid 2-3 inches thick. Okay, here's some more. These ones here were actually not inside the entire time, right? But again, these are seed fall from breeding projects that I'm doing, and kind of some base. This one has a lot of Hindu Kush in it as well. Here's a plant that actually has been sitting outside doing just fine, right? You can see some frost damage, but where the problems happen, hopefully we can see this just fine, is when you get down to about 16 degrees with this particular, some of the genetics I've worked with, you start exploding the stem, and you can see the stem here hasn't exploded at all. It's solid. But if you're peeling off with that much pressure, your plant is dead. Anyhow, that is a lot of what I wanted to show people here is these things will survive extreme temperatures. And actually here, let's see here. Hopefully I can get this to show as well. These ones are getting stepped on. These are getting trampled. The chickens have been chewing on them, right? And so these ones are direct into the ground. And if we get snow, these ones will survive. Okay. But if we don't get snow, the probability of these things surviving is pretty small. But they do pop up all over the place. When we hit the February, we get back to 10 hours of light. We're way below 10 hours of light now. We're late November 20th, I believe. Okay. So, so over here where I'm going to show, gosh, it's kind of hard to see this stuff, but this one in particular, That one was planted outside of the irrigation and was not watered this year. We're in an extraordinary drought. But throughout these, you can see all sorts of plants are growing in here right now, right? We've been hitting pretty cold. So it's not like it's impossible for plants to grow. These are cilantro and wildflowers and carrots. This here is a hemp stalk. These are all hemp stalks. And I went through and actually thinned all these. This is after they've been grown, but these are natural crafted. I don't plant this. I completely dry farmed in here. We had less than 2 inches of rain, and I had stalks that grew 2 feet tall. Okay, so not everything's going to grow. Not all seeds grow that fall out, right? But there's quite a few. I get a couple hundred plants have grown there, and I had to go through and thin them. There's so many of them. Now that's some of the base genetic of that was a ditchweed, a wolf, and that was hybridized into some of the higher CBD quantities, right? And so that was just 3 years ago. I did a breeding project, and the seeds dropped, and I just let them go fallow or feral, let them do their thing. So one of the things that, like, taking your modern genetics, you're not going to have very great success with like a 10-pack of seeds and trying to get things to go wild like that. In nature, think about like a sea turtle, anything. You're going to have a couple of plants out of every 10,000 seeds in nature, right? For like just natural crafted plants. That's how things happen. So we want to take a large quantity of plants and a seed. So if you got something you want to see if it'll work in your area, one of the things you need to do is take that 10-pack and expand the seed and do a mass production of it. And you don't necessarily want to be pampering your seed to germinate it, because in doing so, you're removing that natural selection. But after you've increased your seed and you've got enough you can try a couple of different techniques of broadcasting. You want to look for a planting rain. When's the soil most? And when's the soil going to be able to sustain a taproot and allow it to really dig down in? Now, these little seedlings I just showed you, they're sitting there and they're not really growing a whole lot. There's not 10 hours of light right now. But what they are doing is developing a root system. What little energy they provide, they're not exposing themselves to the detriments of the cold, right? They're going down in and finding that life zone. Of course, here we get like a 10-inch deep freeze plate, and we drop below 20 degrees for months. So the probability of them sustaining surviving through that is small. But again, if it's covered with snow and insulated, it's not exposed to those extreme temperatures, and the ground doesn't actually freeze solid. So in places where you have light freezes, you have frosts and stuff like that. Southern California, for instance, it's brown most of the year, and they get rain in October. Now, depending on where you're at and your soils, and if you can sustain that, you notice all the grasses there turn green in the autumn. Right, the leaves are losing the trees are losing their leaves and such, and so there's this understory that grows with forbs and things like that. So wherever you live, you want to pay attention to that natural cycle that's going on with the native plants and things. Okay, and you're going to test those times. You're not going to necessarily throw everything you've got at it, but test those times. So things need light, things need water, right? Things need nutrients. But how much of all these is a big misnomer, I think. Okay, like a jump ahead. One of the big things that's allowed me to do these things I do with this dry farm and this natural crafting is not utilizing full direct exposure to the sun in the heat of summer, right? Because it can get to, not only is it freezing, but it gets over 104 degrees in the desert, right? And the solar UV is so intense it literally can like cook plants, okay, that aren't able to cool themselves and such. So there's a bigger picture than just when you start, but where it is and things like that. Where's moisture if you're limited, going to accumulate. And there are ways that you can manipulate that with ground cover, mulch, windrows, large pits, north face planting instead of south face planting, right? All these things are going to add up to how and whatnot. I used to do work for the state of Utah, trimming trees to control water flow. We would cut trees off of mesas to increase stream flow for trout habitat. Okay, all of this stuff interconnects. This is great here. I just, here's another one, right? That one might actually survive right here next to the greenhouse. Kind of crazy. So, I got someone joined. Hey, how's it going? Thanks for joining us. So yeah, you're gonna get a seed increase of this whatever genetic you've determined that might plausibly work in your location, and you're gonna want to try in the fall when things green up. You're gonna want to try broadcasting before things freeze up and whatnot, so they're there in the ground when the ground thaws. It's generally the mid-February full moon around here when everything, not just my cannabis seeds, but everything just starts popping out of the ground, and the ground can be still frozen for a couple of inches at this point. And things will grow up, and in the morning the ground will be frozen from the night frost, and you've got these little seedlings, just like these little ones I've just showed you, are popping up out of the ground, and they're surviving these deep, hard freezes every night. So the plant is way more hardy than we tend to think because of years of growing in a closet under a light with plastic bags and paper towels, pampering in the nursery. Okay, so that alone, natural selection, we've bred out a whole lot of stuff that is able to survive these harsher natural selection elements, right? Things are capable of doing a lot more than we think because of the paradigm of production, right? So when we allow these seeds to germinate naturally, when there's ground moisture and without watering them in, they're going to grow to where the water is and where the nutrients are. They're going to, if they can survive, they're going to do it. Right, life begins and it goes, and nothing's going to stop it if it's possible. So things. I prepared an intro slide for this, and this is new. I don't know how to put this on here. I'll use it for a more refined edudoc on the subject. But I have photos of cannabis plants growing straight out of cracks in granite. Okay. And I'm sure you, if not, you know somebody who have seen a seed that was thrown out while cleaning a bag on a porch at a party, and it's growing out of a crack in a sidewalk, right? The stuff will grow. We just got to let it and understand it and realize what our locality is going to provide. Okay. So that taproot drops down in. And for instance, like I was saying, in California, it's pretty harsh there. You know, you get maybe 10% of your rain falls, 5% of it falls in the autumn, and you get green up, and you can get seeds to grow. And they're gonna sit there, and people freak out. It's like, well, aren't you gonna get like Hermie problems from it growing in low light and these things? And no. There's the next thing that people don't seem to understand, that there's this myth of putting plants out too early is going to cause hermaphrodization or re-vegging because it goes into flower too soon and stuff. And so there's this major misunderstanding that comes from sexual maturity of the plant. So if we think about human beings, we only are able to reproduce after we've passed puberty, right? And so plants are quite similar. They're generally, they need to go through certain stages to be able to have the capacity to reproduce. And so even if you put a seedling in, direct seed into a 12 and 12 system, you'll realize that it needs to grow for a certain while before it's able to start flowering and reproduce. And you can see those sex traits, right? Plants need more than 10 hours of light to grow. And So with that in mind, when we're in the wintertime here and seedlings are just sitting there, they don't have enough light to do anything. They're just kind of sustaining themselves, and but they're rip roaring and ready as soon as that 10 hours comes, right? But even then, they still need more than that to get to where they're sexually mature, and so they don't necessarily turn into a flowering plant before the flowering cycle that occurs in the autumn, right? Um, so we have like tropical sativas will grow. They only have 13 to 11 hours of light, 11 to 13 hours of light, and they can grow for 18 months in veg before they trigger and trip into flowering. So there's a lot of plasticity in what's going on, but people don't quite understand that because we've all been trained to grow in a closet and this commercial production, maximum yield, maximum returns of THC, and we leave out so many other concepts of what's going on with this plant. So we got taproot dropping, we got some leaves growing in the spring. More water comes, the spring comes and gets spring rains, and the thing will start growing pretty good. Um, but again, it's not going to go into sexual maturity and start flowering because that's just the natural cycle. It doesn't do that, right? That's something that comes from us growing things in a nursery under lots and lots of light, and then taking it and putting it into a completely different lighting situation, a completely different temperature range, water range, all that stuff shocks it and confuses it, right? But if it flows through the natural cycles and the natural circadian rhythms, then the plant knows when it's time to go, right? In Morocco and the Atlas Mountains, it's a whole different. They've got a genetic that's developed where they're on that super high elevation. There's not a lot of heat and stuff, and that Belledia, that stuff they plant it. They start plowing in March. Then they're planted by May, and they're harvesting in July. Okay, it's a very different thing, but we can adapt all this stuff over time to work with our own systems. So California, again, Southern California, you got that fall rain, and then the spring rain comes in March and April, and then it goes dry. And if you've been watering your plant, right, it hasn't followed the water that came naturally. And so it's going to have a high in the soil profile rooting system, right? It's going to go where the water is. But if you don't water it, it's going to go where the water is, which is it follows it down into the ground. Okay, it spreads out its roots and it finds the moisture. And then the other thing it does is, if you look around, like all the plants that are growing out there that aren't in someone's landscape irrigation, they're all growing fine, aren't they? Right? Every year you got sunflowers growing all over the place. They're growing fine. Nobody's watering those sunflowers. Okay, they start out a lot more lush and they harden off. And the exact same thing is going to happen with this cannabis plant. As the moisture recedes and the temperatures rise and the relative humidity goes down, the plants naturally adapt. It hardens off. It might drop leaves, right? It might lose some larger fan leaves. It might just let them hang loose to hold moisture in. But this works. Okay, it isn't just cannabis that it works with. Okay, this has been done for hundreds of years with all sorts of crops. The crops have to work harder, and so they have a denser cell structure and higher nutrient density, right? There's not all this water fluffing the plant up, the cell structure of the plant up. It's denser. It's in these denser cell structure is more impervious to disease and insect. Okay, you see where we're going here. All of a sudden, we don't need to be adding all these pesticide actions. We don't need to be utilizing as much IPM inputs because the plant itself is secured itself against the environment, right? And so we have this plant that has this intense autoimmune system that's set up. It has its cell structure is starting to solidify and everything, right? And it's going to produce the milk of the earth, what is there to be offered, right? It's not going to be taking in input from someplace else, right? We're not creating an energy flow to of waste streams, pollution and things like that to bring water and nutrients or whatever to this plant. It's doing all the work on its own because that's the natural system that's been developed for over billions of years. It works, right? And it's our own greed and desires that make us need to, of course, agriculture we developed, and there was a natural flow in agriculture to get to where we are today, and the natural flow is to look back at what worked and in the past and why and how can we adapt to that. So that's really one of my great goals here. So this dense plant that we've now starting to form up, it's grabbing all the nutrients that are available and the balance that they're in, and that sets the tone for our terroir. Okay, this is where we're going to get these incredible flavors, these amazing rich terpene profiles that are not going to be found in something that's just pumped full of nutrient. Okay, this is in dry farm food gardening. They talk about the brix levels that are increased and such, and the food density flavor, the flavonoids, the colors, everything are so much more intense in these systems. And so when it's growing along, you're never going to get quite as much. You can get some great yields, right? But of course, if you're pumping fertilizer and water in, you're going to get more. But what is the cost of that, right? You're living in California or someplace where there isn't clean water, clean access to water or wells or whatever it is that you need your water. It gets expensive, right? And the fact of the matter is, it's not really needed. Okay, so what's the worst case scenario? A protege of mine in California just gave me a report stating that, and of course there's genetic changes and things like that, but a couple of years back when they first tried this, they got a 3-pound plants of a dry farm, and this is in Central Coast desert zone, right? But that's 20 inches, maybe 30 inches of rain. Okay, this last year they got a total of 10 inches of rain, and 7 of it fell in one storm. So essentially they got like 4 inches of rain. Okay, and they reported quarter-pound maximums on their plants. One plant that was watered a little bit got some more, right? So that's a pretty extreme scenario, right? But here I am in Utah and sand and the hemp, where I do fodder cuts just to test to see how it's doing and whatnot. I got a 9-foot plant with 2 fodder cuts and 2 inches of rain after the ground thawed. Okay, these are the realities of this, is that as long as you space things and you time your planting, right, whether it's broadcast or direct seeding before a storm, these things are going to work. So we can have a dry farm where we actually have a field prepared with windrows and ground covers and cover crops and all that stuff, right? You're going to space things out just like the Navajo and Hopi do with their corn. You don't plant them 6 inches apart. You plant them 8-10 feet apart. Okay, that gives room for those roots to spread out, and they're not competing with each other and sucking the ground dry. But then you can get into natural crafting and wild crafting, and that's a whole nother thing that I've spent years and years and years working out how, where, when that kind of stuff can work, right? And so you're going around broadcast seeding and or prepping special spots, right? But you're not necessarily digging holes and adding things to the soil. You're looking, and it takes time and takes energy, and it takes a lot of seeds to find these things that are going to work. But you got to find a place where there's naturally the soil holds some moisture. Steep south facing slope pretty much is not going to work in most places. It's just too hot and it gets too dry. But if you go into that north facing slope, you can find there's moisture holding in places, right? You can think about riparian zones and the variable source area, the expansion and contraction of riparian zones. And some of my earliest work with trying to figure this out, I was transplanting things right in next to creek beds, right? But then you have all the nutrient leached out. Okay, so where you plant these things it makes a difference, right? There's also in the riparian zone, there's not enough light. How much light do you need? You really only need 4 direct hours of light every day. So if it's shaded and you're in a super hot area and it doesn't have much moisture and it's intermixed into a mixed canopy forest, as long as you've got a pocket of light. Okay, you can see back in the 70s and 80s, there's occasionally you get to see some imagery of folks who are talking about this kind of stuff. You'll see some video or some footage or photos of people walking into deep woods, and depending on how deep the woods they were, there's some pretty lanky looking plants, right? But they're literally just growing in that understory with very little light. A whole nother one you can do is in the heat of summer, the sun's directly overhead, right? You can see this pine tree over me right now. Okay, its shadow now is in the neighbor's backyard, but in the middle of summer, it's directly where I'm standing. Okay, so it provides shade for. I grow in this zone right here. I'm gonna flip here. You can see I have a zone of shade here that I'll grow. For instance, and this isn't dry farm, but this is just dealing with the heat and stuff that we get here. I'll grow lettuces in that zone, and it's under the shade of these different trees. And let's see, I've got my tablet's all over the place here. So if you think about that, like some of the stuff that early guerrilla grows that I did in California in the early 90s was planted along the edges of like a eucalyptus grove, right? And so in the heat of the summer, that eucalyptus grove not only hid from helicopters, but as well it protected from that severe heat. And then in the flowering season, and this is something actually I picked up as well from Native Americans, right? The cliff dwellers. And in the heat of summer, it's flipping hot, and that sun's directly over the cliff, right? In the winter, it's lower and it aims right in and it heats the walls of the buildings that they created. We do the same thing with eaves on our roofs in our homes. Okay, so all this is just simple concepts that we can integrate into adapting to natural crafting in extreme environments, and not necessarily the Erie River where they get 70 inches of rain and they don't have to water because the groundwater is so much. Okay, but that just makes it even better if you have that kind of stuff. That's and well, I never even defined dry farming. Truly is under 20 inches or even under 13 inches of rain. Okay, so looking at like what the Hopi and Navajo do, and all over the state of Utah, corn, beans, and grain primarily. Idaho has huge amounts of grain that's just dry farmed, and it's a doable thing. So let's see. I said I was going to touch on 5 aspects. I don't want these to be super long, but I think I've shown here that the dry farm is a doable thing. I'm going to repeat these concepts in different aspects, different ways, but I really wanted to show how these little seedlings are doing their thing, surviving in some extreme cold temperatures, and depending on where you're at, right, you can develop these terroir. And I think a lot of people think that terroir might be developed from the style of growing you're using in an area and additives and stuff, but truly it's getting past all that super soil and things like that, and maybe adjusting if you have extreme alkali sand here. I need to add stuff at my specific locality, but up on the mountain in my sacred plot, that's the true terroir where I added absolutely nothing, and it's the side of the mountain, it's the decomposed granite, and it's the fir trees, right? It's the brush, it's the spruce and the pines and the Douglas fir and all the fungus and the plants and all that stuff that adds up. And that's what truly creates the terroir, right? It's the striving against the elements. It's the temperature exchange and all of those things. Okay, you're not going to create an appellation of any sort growing indoors. That's just not. And it's also going to be tough to create those appellations by amending your soil intensively, right? Or any sort of intensive agriculture to this plant. So yeah, I wanted to show how we can set seeds at different times of the year. Let's see, Method Terroir. I didn't write any of this down. Pretty sure I covered what I was gonna cover there, and it's a little teaser. This stuff was all supposed to get chopped. We'll go ahead and take a. Like I got some elites in here. Let's see. I know it's a terrible camera. Well, here's hash plant. This is the North Utah hash plant. What's left? I got a couple seeds in there. This is GMO. This here's slurry cane. These are not dry farmed at all. Indoor. What we got here is gelada, rainbow sherbet 2. This one is the grape pie and the peanut butter souffle. Oh, even better though. This is Dr. Dream Malt here, and I defoliated it yesterday, but stuff grows. Appreciate you guys for stopping in. Let's see, I got the kind crew and Smiley in the house. Appreciate you guys. And no questions. Cool. I'm gonna end stream and we'll do this again. Thanks, guys.